Good morning, good afternoon, and good evening, everyone, based on wherever you are. A very warm welcome to you, all of you. Thank you for joining us today for Powering Your Future with AI Enterprise Webinar Series. I am Mansa Rao, and I'll be your host for today's session. This is the second webinar in our series, and today's topic is an exciting and highly relevant one: predictive analytics through MLOps on Databricks. Now, if you think about the world we operate in today, organizations are sitting on massive volumes of data from customer interactions, transactions, operations, and even external signals like market shifts or global events. But raw data by itself doesn't create value. What enterprises really need is the ability to predict, to look ahead, to forecast demand, anticipate risks, personalize customer experiences, and make smarter decisions faster. That's where predictive analytics steps in. And yet, as many of you would know from experience itself, building predictive models is just one step of the challenge. The bigger challenge lies in taking those models to production, keeping them updated as the data changes, monitoring their performance, and scaling them reliably across the enterprise. This is where MLOps becomes so crucial. Just like DevOps transformed the way we deliver software, MLOps is transforming how enterprises deliver AI and machine learning. And when you combine the power of MLOps with a unified data platform like Databricks, you unlock the ability to seamlessly build, deploy, and manage predictive analytics solutions at scale. Sorry. At Exponentia.ai, we've had the privilege of helping clients across industries, from financial services to real estate, insurance, and telecom, leveraging Databricks to solve real business challenges, whether it's enabling faster compliance reporting, building predictive pricing engines, or creating scalable data pipelines. The impact has been very real. Improved decision making, faster time to market, reduced costs, and enhanced customer support. So that's the focus of today's webinar: analytics, predictive analytics through MLOps on Databricks. Over the next 45 minutes, we'll explore what makes this combination so powerful, real world use cases where it has been delivered with measurable impact, and practical insights you can apply in your own organizations. Here's how we'll spend our time today. First, I'll introduce our speakers who will bring deep expertise in this space. Then we'll dive into a panel discussion where we'll cover both strategy and execution aspects of predictive analytics with MLOps. And finally, we'll open it up for some Q&A so that you can just keep your questions coming in through with the chat window. Now, let me introduce our distinguished speakers. Rohith Kumar. Rohith is a senior data scientist with over 6 years of experience designing and deploying advanced analytics and machine learning solutions. He specializes in platforms like Spark, Databricks, AWS, and Azure, and has successfully delivered production grade models, scalable pipelines that power business critical decisions. We're thrilled to have you today, Rohith.
Yeah, thank you, Mansa. Hi, welcome everyone.
Also with us today is Viresh Manjarekar. Viresh leads the Databricks Center of Excellence at Exponentia, overseeing a team of more than 75 Databricks practitioners. With over 7 years of experience in data and AI, he has spearheaded several critical projects delivering predictive analytics solutions with MLOps on Databricks. Welcome today, Viresh.
Hi, Mansa. Thank you for the warm welcome.
So now Viresh will help us understand how do we cover up predictive analytics using MLOps on Databricks. Over to you, Viresh.
Thanks. So, before we dive into what is MLOps, what is the predictive analytics use case on Databricks, for all of us who are joining us for the first time, I would quickly want to introduce you all to Exponentia. So, quintessentially, we are a global data and AI consulting firm, which is singularly focused on data and AI. This deep specialization actually allows us to go both broad and deep within this domain. We have a team comprising of more than 460 consultants with a global footprint across multiple geographies. You can see here in that particular slide. We also hold very deep partnerships with all the prominent hyperscalers, maintaining an advanced tier status with each of them. So, for example, with Microsoft, we are an ISV partner. With Databricks, we are a select consulting partner. We're also their DPP partner. For AWS, we are their advanced tiered partner. With Click, we also have an elite partnership. And here is a select list of customers that we have worked with, because through these strong alliances with the partners and the hyperscalers, we are also a part of their partner advisory councils. And this has helped us serve numerous of these Fortune 2000 customers across diverse geographies. Can we move to the next slide? So, having introduced you to Exponentia, we would now walk you through the solutions that we are catering to. So, we provide a very specialized consulting service for established and comprehensive data and AI practices, which include roadmap development and governance framework implementation. A significant portion of our work involves modernizing data and AI platforms, because here we leverage Databricks to extensively build new enterprise grade data and AI platforms which facilitate migration from to modern lakehouse and also help us implement the enterprise AI governance with the help of Unity Catalog. We also have AI product engineering, wherein we have empowered organizations to build robust data and AI products. A primary example of this is the Xanadu Decision Engine, an AI-ML solution which we developed encompassing the entire data footprint from end-to-end platform setup and integration to ensuring data consumption. This showcases our strong product engineering capabilities, wherein we also have ability to embed agentic AI agents, such as the solution developed for another of our prominent customer. We also provide ML analytics solution for impactful business dashboards. So today we will be focusing on the predictive analytics or predictive modeling use case, where we'll deep dive into how do we power it up with the exponential implementation model. Now, with the credentials that we carry with Databricks, as I initially informed, we are the select partner with them, and we are one of the fastest growing and the largest center of excellence that Databricks has within the APJ region. We harness the power of the COE to drive delivery excellence across the select Databricks logos that you can see on the screen here. This has helped us make the Databricks practice of more than 100 practitioners, from which 75 have successfully certified themselves on the Databricks platform. We have also been rewarded with laurels, as you can see here, and I mentioned that we are a critical part of their partner advisory council as well. Here is an overview of the platform modernization offerings that we provide under Databricks, where we start from accelerated lakehouse setup. We have Unity Catalog migration powered by UCX. We also enable SAP Databricks migration. We have migration to Databricks powered by LakeBridge. Along with that, we have our own GenAI products and the critical offering which we are going to look deep into, which is predictive analytics using MLOps. Now, these are the few use cases which we have powered up with the help of the offerings which I mentioned previously. As you can see, the customer Solo Homes, which is a US-based real estate entity, for whom we powered up an MLOps use case to help them accurately list their real estate pricing, real estate offerings on their particular portal. It also dives down to the use case which we delivered with Xanadu, wherein we built the Xanadu Decision Engine. Both these projects were successfully delivered on Databricks, as a result of which we were able to publish a joint case study and a blog for each of these interventions that we carried out. We would be touch basing on these interventions once we take you through what this particular offering is, how exactly do you build an MLOps model on Databricks, and how do you power up that use case. So there is more to follow. Now coming to the meat of the discussion, wherein I'll introduce you to what exactly is MLOps on Databricks. So this, in simple words, this offering is purely about building or leveraging the MLOps as a single unified data on the single unified Databricks Lakehouse platform to drive accurate and data-driven decisions. By taking this approach, enterprises can seamlessly build, deploy, monitor, and continuously improve predictive models to ensure reliability and long-term consistent performance at scale. The core capabilities of these offerings are unified end-to-end workflow, where the entire machine learning life cycle, right from data ingestion to model development, is managed on one single platform. This approach ensures consistency and fast experimentation while significantly reducing the operational overhead. The second step is model governance and versioning, where using MLflow, we can maintain a complete lineage and audit trail for every model. This capability allows all the teams to compare different versions, roll back a few versions if required, and ensure full compliance, security, and reproducibility. Then we also have focus on providing real-time predictions because in these FSI models, real-time business requirements are a top priority. So we deploy models which can serve instant results to business applications and dashboards through the means of REST APIs or batch pipelines. This enables real-time business consumption and powers decision making. Finally, we offer continuous monitoring and automated retraining, where the platform continuously monitors the model accuracy and provides automated alerts for data drift or performance drops. Whenever the thresholds are breached, the systems get automatically triggered into model retraining and thereby maintain performance. Here's a look at the considerable advantages which you can leverage through this offering, where you get an accelerated time to market. It helps automated pipelines from data ingestion to reduce the development pipelines and thereby businesses to quickly respond to any market changes and opportunities. There is reduced manual effort and errors because there is automation brought into the system for retraining, for monitoring, for versioning, which overall minimizes the human intervention. We are offering scalable and optimized cost management so that Databricks is giving you a seamless model to handle large data sets and models. It also optimizes resources with serverless options, which have been made GA in the geography just this year. Along with that, we have reliability and transparent prediction. So the continuous modeling, monitoring, and retraining ensures that the models remain aligned with the real world data. This combined with MLflow ensures that the outputs are interpretable, trusted by business teams, and overall that reduces the risk and increases the confidence with the customers as well and with the enterprise teams as well. Now that I've explained you what are the business elements or the functional elements of this offering, I would now like to invite Rohith to give you a deep dive on what is the technical implementation aspect of building this offering. So over to you, Rohith.
Yeah, thank you, Viresh. Thank you for that functional explanation of predictive analysis on Databricks. I welcome all with warm greetings. And let me start with the technical aspects wherein we do this predictive analytics based on MLOps on Databricks. So, as Viresh explained, the functional attributes. In the technical attributes, we need to take over these functional attributes into an implementation path. So for this implementation path, whenever we are working on a data driven solution, uh, for the MLOps to work properly, to get automated and to have all these advantages, Databricks is an best platform wherein we can use their, like, the MLOps features are the core capabilities of the Databricks. So they are directly proportional to each other. So as per the four components or the four checkbox, whenever we do and project and find a solution, the four checkbox which are to be ticked are this functional requirements like unified end-to-end workflow, which Databricks provides with its data lakehouse and all other singular workspace components, and from the to complete all the ML lifecycle from the data ingestion to the deployment. Then comes the modeling part, wherein we have the best workspaces, best provided built-in modules for doing our studies, making the research, and creating that raw data into an subjectable matter where we can use it for the business. So this checkbox is also ticked on the Databricks, where model governance and versioning can be done with very ease. Then continuous monitoring and automated retraining. We have this SQL analytics on the Databricks backend, but also Databricks provides the monitoring and logs for every part of it. And automated retraining is just a part where you link up and you frequent out the workflows, which directly retrains, which reduces our unnecessary works of creating again and again or replicating the same work again. So minimizing these things, this box also being checked in Databricks. Then the real-time prediction and business conception, the end layer where the user is going to analyze us, wherein we would have this real-time batch predictions and the BI layers, wherein this silo is also ticked in Databricks. So all in all, the Databricks is a one-stop solution for any data driven solutions. So moving forward, for the implementation approach on the any predictive analytics or any analytics within the Databricks using MLOps. So can we move one slide further? Yeah. So the implementation approach in the technical basis we take is the businesses have their own data. So the data might be in any form, they can be of any category, but they need to be pulled up and they need to be utilized. So for that, we have data ingestion that in Databricks backend, we can connect with any cloud storage very easily and very smoothly. So this in this we follow the implementation approach of storing those cloud storage, like storing those datas into the cloud storage in the raw format as they are. Then we follow those medallion architecture, wherein we go for the step-by-step cleaning of the data and utilizing the data for the further analysis and use cases. So we can go through bronze tables wherein we do the data engineering stuffs like data processing and analysis, where the whole ETL part is being done and the data is made sane for the utilization of the next process. The silver layer, where we can use our ML features or ML trainings, model developments onto a singular workspace where cross teams can collaborate together with the necessary cluster capacity and other all things, so that we can do this in the silver table where we can uh, granularize the data, make it useful, make it meaningful, and move forward to the goal layer. Wherein this goal layer is the part where we utilize the data further. So this data are being converted and placed in such a manner that the data can be bifurcated to any consumption. Like for the MLOps, we can go for the ML workflows, ML workings, where we can do the modeling, registering it, creating them into an endpoint for the consumption. In the BI silo, we can consider them for business decision making, where we provide out the dashboards, which have fantastic visual capabilities and built-in modules, which can provide infinite performance KPIs as per our scripting technologies and other things. We can have the business decision making over there on the BIs. So this is how we capture the data. We make them, like we do our ETLs, we transform them and utilize them on the consumption layer. So moving further, talking particularly about, can we move a slide further? Yeah. So talking further about the solo homes, solo homes is a particular place where we have utilized the full capacity of the Databricks. So the challenges addressed in the solo homes was that in the real estate industry, there were inconsistent property valuation, lack of actionable data by, like there were not actionable data which can be used or utilized on the real time. So here we try to use those inconsistency and lack of actionable data by providing accurate prediction and real time insights. The project empowers the stakeholders to make informed decision about property investments and pricing strategies, and identifying the trends to optimize the buying and selling process, streamline the real estate operations with automated tools and workflow. If I talk about the solo homes property price prediction project, it is a comprehensive data driven solution aimed at accurately predicting property price by leveraging advanced machine learning techniques, scalable cloud infrastructures, and automated workflows. The project utilizes Azure Databricks as its primary platform for implementing this end-to-end data pipeline from ingestion to deployment, ensuring seamless data processing and analysis. So the main objective of the project is to provide the stakeholder, including the buyers, sellers, and investors, with actionable insights into housing price based on historical trends, macroeconomic data, property attributes, by integrating machine learning models and orchestrating data processing with the cloud tools. So here we, in the initial stage, we had several datas like the macroeconomic data, the property features. All these data are dependent on the price of a property. So we had the raw layer wherein we try to pull up all the data into an Azure blob where we stored all these dependent data sets which were dynamic, which were changing, which were moving as per the market. So they can be utilized into the further study, and we can solve this business flowbacks where they were not able to make those decisions, the customer gaining properties and all things. So from this we try to move it on, like we got it in the Databricks backend. We saved them as a delta table and delta live tables which were utilized into ETLs, wherein we transform the necessary features, variables which are important into the useful tables. Then the consumption layer was utilized, and then in Databricks we have several modules inbuilt which are very useful. Like if we can consider bagging, boosting, we can trial out everything under an experimentation tab. So nothing goes here and there. We don't miss out on anything. Every cross team works on a single platform, utilizing everyone's work without any replications. So here we used LGBM as the model. So we try to predict the price. We try to give the customer out the predicted price in such a way that we did our whole process in an controlled manner. We try to extract the features from the raw features. Like we try to extract importance of the feature. We only use those features without considering more uh, like complicating the model, and we just try to stick and like extract our own problem solution. So in this way, we use the machine learning capability of MLflow, like on Databricks, like MLflow, other data pre-processing techniques, and we created a solution wherein we have impacted the solution very much. So I would think I would rest my part and would allow Viresh to explain the impact we made with this on the client's feedback. Thank you.
Thanks, Rohit. That was a very detailed explanation of not just the offering, the technical approach, as well as the case study. So, as you can see, with such a comprehensive solution, we were able to achieve a 93% model accuracy. This high precision of price prediction allowed Go Solo Homes to confidently list properties at a very competitive price without having the risk of overpricing or underpricing. The operational efficiency they gained was mainly through the automated data pipelines, which helped them reduce manual labor and allowed for quicker and more informed decision making for their customers. Where there was a considerable growth in the customer satisfaction score at Go Solo Homes, where the ability to offer more accurate valuations proved to increase their trust and have the better engagement so that it directly converted into an enhanced sales performance. And finally, with a scalable architecture like Databricks in place, we are sure that Solo Homes will be able to grow their data infrastructure and adapt to the needs of the new markets and data volumes. Now, having covered the case study of Solo Homes, I would like to elaborate that we have successfully published this intervention with Databricks as a blog, which is available for public preview. With this, I will now step aside and allow to give you a live demo of how exactly we build an MLOps model on Databricks and how do we power up a predicting use case on the FSI sector.
In this demo, I will walk you through our end-to-end pipeline for predicting accounts pay past due, a key metrics in credit risk analysis. We will showcase you the entire pipeline from data ingestion to dashboard delivery. You will see the methods, tools, and the insights we use to help banks proactively manage credit risk and improve lending strategies. So the problem statement of our project is to predict which loan accounts are likely to move into higher DPD buckets, enabling proactive credit risk management and timely correction interventions. So we would actually showcase you, provide a walkthrough of the data itself. So we have the independent variable as well as the dependent variable in this case. So coming to the variables, so we have some principal write-off amount. We have the total number of the bounces, the count of the bounces of the loans, high credit CC, the write-off amount, the count of the delayed loans between 30 to 60 days, the median credit card limit, some write-off amount, credit secured loan, and also we have target 30 DPD, which is our target column in this case. So in in the model training part, so here we have actually imported the required libraries for our project. So coming to the scikit-learn. So scikit-learn is a popular open source framework used for machine learning and data analysis. So we have something called as a pandas library. So pandas is also a popular open source framework for data manipulation and analysis. We have, so first coming to why Databricks, because Databricks as a platform is a popular choice for machine learning due to its unified platform, which streamlines the entire machine learning lifecycle from data preparation to the deployment. It offers features like central workspace for collaboration, pre-configured ML environments with popular frameworks like MLflow for model management and experiment tracking. So here we have actually defined our catalog schema and the training data. So we have loaded the data from our CSV into a workspace. We have converted the Pandas data frame into the Apache Spark data frame. So Apache Spark is a versatile open source distributed computing framework designed for large scale data processing and machine learning. So we have actually Databricks provides a additional feature called as a feature table. So feature table is a structured way to organize and manage features used for machine learning models. So any delta table with a primary key or index can be used as a feature table. So here we have actually created that particular feature table with the index as a primary key. We have provided the data frame. We have provided the schema of that particular data frame as well as the description. We have created a training set out of this particular feature table. Coming to the setup, so here we are actually setting up a model registry within a Unity catalog. So Unity catalog is a unified governance solution that simplifies data access, security, and lineage management within Databricks platform. So here we have set the registry URI for the Databricks Unity catalog, and we have initialized the MLflow client for managing the model as well as logging the various parameter metrics of our models. We have set the experiment. We have set the experiment path. So experiment is nothing but it consists of an collections of various runs. So here we have actually defined this particular run of a data resampling because the data that we are going to use for our model training is actually imbalanced data. So we need to balance the data in order to avoid the biasness within our model that is being trained. So here we are actually using the balancing technique to balance our target column. So here we have actually splitting our data into the train and as well as test. So the training data would actually go into our training, the machine learning model, whereas we will be evaluating our model on the testing data set. Then hyperparameter tuning. So this is an important concept within a machine learning model lifecycle, whereas we will actually tune the various parameters of our machine learning algorithm in order to get the optimum model. So here we have actually defined the search space of our model. So within the search space, you can actually customize the parameter that you would actually want to tune to get the best model. So here we have defined this certain sets of these hyperparameters. You can vary this parameter based on your requirement as well. So we have defined the objective function. So objective function, what it does is that it will actually try to minimize the loss or the error to get the best optimum model. So here within this particular run, we are actually performing the k-fold cross validation as well. To get the optimum model, we are logging the matrix using the MLflow framework. So the metrics that are being logged are AUC. AUC is nothing but area under curve. So it's an graph between the TPR and FPR. and this particular AUC will actually will give us the model performance. The range of AUC is 0 to 1. The more the value of AUC, the better the model performance it is. Here we have error. We have AUC-PR, which is area under curve precision recall curve, which is again an evaluation matrix for a classification problem, and log loss as well. So here we are actually using Spark, Apache Spark to tune, to parallelly train various machine learning models. So we are using a framework called as an HyperOpt, which actually supports the training multiple models parallelly in the same go. So here we are actually tuning this particular machine learning model with a HyperOpt framework. We have set up this objective function. We have defined the search space. We have actually defined the algorithm as TP. TP is nothing but tree parser estimator. We have actually provided the trials and the max evaluations as well. So what HyperOpt will do is that it will tune the various hyperparameters and evaluate the model across each trial, and it will provide us the best model out of this particular set of models. So after the hyperparameter tuning, we would actually get the best optimum model for our particular use case. So we are actually registering or logging that particular model within our ML using the MLflow framework. So here we have actually defined a special run called as XGBoost model training, whereas we have actually disabled the auto logging. So we are doing here manual logging. Manual logging gives us the liberty to log the customized parameters, metrics, model, artifact, which is not possible with auto logging, which logs predefined sets of parameters, metrics as well. So that is manual logging provides us the edge over the auto logging. So we have actually initialized this XGBoost model with the best hyperparameters. We are training the model. So we have actually logged the parameters of our model. Here we are actually inferring the signatures of our model. And here we are actually registering our model in the MLflow model registry. So we are logging the test metrics like test accuracy, test recall, test precision, test F1, test AUC. Similarly, we are logging the parameters for the training dataset as well. So here we have actually computed the confusion matrix, and we have plotted the confusion matrix along with the feature importance plot. So the confusion matrix and the feature importance plot are the important metrics for an classification problem. So we will deep dive into this. So a confusion matrix is a matrix consisting of an actual values of a target column and the predicted values. So it consists of four parameters for a binary classification, like it has true positive, true negative, false positive, and false negative. So true positive is nothing but actually that particular value is positive, as well as the model has predicted it as positive. So it will be called as a true positive. Similarly, for the negative, if the actual value is negative and the model has predicted it as the negative, in that particular case, it will be called as a true negative. In case of the false positive, actual value is actually negative, but our model has actually classified it as positive. That will be classified as a false positive. And for the false negative, the actual value is negative, but the model has actual value is positive, but the model has classified it as a negative. So that is something which defines this confusion matrix. So we have two more evaluation matrix called as precision recalls that are derived from this sets of metrics. So recall is nothing but out of the total actual positive, how many of our model is predicting as positive, that will be the recall. Similarly, precision from the total set of predicted positive values, how much values are actually positive, that would be the precision in this case. Feature importance plot will actually give us the importance of a particular feature in making the final prediction. As you could see here, the total bounces count loan has the highest feature importance among the set of the feature that we have provided. So here, as we could see, the total bounces count loan accounts for a 0.30. So 30% of the weightage in predicting the DPD is allocated to this particular column called as count loan. So accordingly, we can actually analyze each feature and their importance in making the final predictions out. So this is a really important matrix. Coming to the tracking part, coming to the features table. So a feature table is nothing but so it's a delta table with a primary key. So it's perform the data balancing. We have balanced the target column here. Then we have actually performed the hyperparameter tuning. So model tuning with hyperop. This was the run. So here this is the existing model registry. We have actually registered the trained model here. XGBoost model training. We have actually trained our XGBoost model here. So why XGBoost? Because XGBoost is a powerful and versatile open source machine learning library used for both classification and regression tasks. XGBoost outperforms most of the machine learning algorithm due to its parallel tree boosting and to handle the large dataset drive efficiently performance in a task such as in regression and classification and addresses missing values in the live data with speed and accuracy. It is an enhanced version of a gradient boosting. So that is the reason we have opted for the XGBoost model, which actually provides a really great results. So we have actually logged various metrics called as test accuracy, test F1 score, recall, precision. Similarly, we have actually logged the parameters as well. These parameters. We have logged the metrics, test accuracy, test AUC, F1 score, precision, recall accordingly. Coming to the artifact section. So here we would actually have the entire metadata of our model along with its dependencies, like we have the YAML, conda.yaml, requirement.txts, as well as the model files, along with the artifacts that we have logged, the confusion matrix and the feature importance plot. Coming to the registered model, we have actually registered the XGBoost model there. So within this particular model, we can actually maintain multiple versions of our model based on the model performance. So as you could see here, we have various versions. We have version 1, version 2. So this is the initial model version, and the version 2 is the retrained model that we retrain on the newer data, basically. So these particular model are then being used to serve for making the batch predictions. Coming to the batch inference. In the batch inference here, we actually load our trained model, and then we actually make the predictions on our newer data or the unseen data. So here we have actually loaded the required libraries like MLflow, pandas, numpy. Then we have actually loaded the data from the CSV. We have dropped the target column. We have only considered the independent variables in this case. So we have loaded our machine learning model from our model registry, and then we are actually making the predictions out of it. And then we are actually write that particular table into our Unity catalog. Now, okay, coming to the predictions dashboard. So here we actually developed a dashboard to analyze our model predictions. So within this dashboard, we have the parameters called as true positive, true negative, false positive, false negative, recall, precision, which are actually the classification metrics. Then we have actually visualized it using a pie chart as well as the confusion matrix. And here coming to the feature importance plot, we have actually plotted the feature importance plot to get the overall idea about the weightage of each feature. Also the correlation between the each feature. What is the correlation of each feature with our target variable, that is target 30 DPD. And this is the distribution of our target 30 DPD and the distribution of our predicted target 30 DPDs. So this will actually give us the overall idea of our model performance. Coming to the predictions monitoring dashboard. So here basically we would be monitoring the various drift metrics. So there are various drifts like data drift, model drift, concept drift, target label drift. So we would be monitoring each of these drift parameter using this prediction monitoring dashboard, where we will be analyzing each record, like the number of the records, their evaluation metrics, as well as the performance over the time. So here, if there is any such kind of a drift within this data, we would be able to identify that particular drift here, and then we can actually set up a automated mechanism, whereas it will actually, if a drift is detected, it would actually trigger the retraining pipeline and deploy the newer version of our model into the model registry. So if there is any prediction with respect to the numerical columns, so that will be detected using a few of the statistical tests like KS test. We have PSI test, Wasser WD test. Similarly, for the categorical features, we have a different sets of statistical tests to detect this drift, like chi-square test, TVD test, LID test, and JSD tests. So in this way, we can actually manage the complete machine learning lifecycle, right from the data ingestion to the model dashboard delivery, along with the model retraining mechanism, which is an important part in any machine learning project.
Yeah, so with that, we have covered the comprehensive way to showcase how exactly we are building the MLOps model. So overall, in conclusion, I would want to say that by unifying the entire ML lifecycle on a single, scalable, and cost-optimized platform, we are empowering the enterprise teams to deliver reliable, transparent, and high-impact predictive analytics. So, in synopsis, it's not just a technical or a technological solution, it's rather a strategic move to accelerate innovation, reduce operational risk, and drive data driven growth. With that, I set the stage for Mansa to open the forum for Q&A.
Thank you so much, Viresh. Thank you, Rohith, for sharing all your insights. Like you said, we'll move on to the Q&A session now. This is your chance as the audience. Please drop your questions if you want to ask our speakers anything around predictive analytics, MLOps, or Databricks. Please drop them in the chat and we'll try to take up as many as possible. I see that we already have a few questions. Yeah, so the first question is from Kinjal Bunta. Hi everyone, my question is what is the volume of data which we handled for the MLOps project for solo mode?
Yeah, I think once this is the question for me. Thanks, Anil. So here the data we handled was in terabytes. So this is a big data problem. So this is a big data engineering work where we used MLOps. So this terabyte of data was handled on as it is raw. So the first stage where we handled it was on the blob storages where AWS provides separate storage. There are several cloud storages. So the data handling was not a big part, but the volume of data kept refreshing was the big part. And we handled around millions of data points, which were from the like we can, as we said, macroeconomic data, property attributes, and we also had an listing entire website backend, which was called through an API. So we had a MLS listing of the US properties. So this was a very big data engineering project where we had to spend more time on structurizing the data and performing the data work, which had several data points which are to be utilized onto the business solution.
All right. Hope that answers your question, Kinjal. Next question is from Zahir. What are the challenges encountered in implementing the Solo Homes MLOps project, and how did we overcome those challenges?
So the main problem was, as I stated, it was the handling of data, then the interconnecting of several components of our MLOps. So we automated the whole process in such a way that it should not be reworked in such a way. So whenever a data gets refreshed, when the macroeconomic or any stage of data figure get refreshed, the whole thing reflects up to our endpoint. So the main things we're connecting it, like from the data ingestion, we need to connect it to our backend for analysis using those libraries as we showed it on the demo, like the model training, the model registering, and creating the endpoints. Then endpoints in we had directly the users were put in their inputs into the endpoint and they get the response to the backend on the refreshed and updated data. So also we have utilized made possible of a recommendation engine into it, where we recommended the customer, if a customer selects a closed listing, we would recommend them of near 5 properties of that location as per the customer's expectation. So where we try to use all the statistical capabilities which are provided by Databricks and our engineers, wherein we try to calculate the nearest distance, like using the Haversine formula and other things for recommending them the nearest 5 properties, so that the customer doesn't get disappointed and he gets a clear view that the listing is closed and you can check your chances on the remaining provided properties.
Okay. Thank you so much for answering that, Rohit. We have another question from Achal. What are the other use cases that we can power up using MLOps on Databricks?
Yeah, so I'll take that up. So there are like MLOps is not just about deploying a model; it is actually about powering up an ecosystem of all the advanced use cases across industries. So a few impactful use cases that are on top of my mind. One is about fraud detection in the FSI domain, where deploying streaming ML models on real-time transaction data will help in having early fraud detection, which is a very bigger problem in the FSI domain. Then we have customer 360 on personalization use case, wherein we would be able to have personalized suggestions and offers given to the customers, which help them get offers or get requirements curated to their needs. Another prominent use case is the credit risk analysis, where the models are versioned, auditable, and they are reproducible for having an optimized credit risk for any investment or any funding that is to be procured. And lastly, there is predictive maintenance for like the manufacturing domain. So we can combine the IoT sensor data with MLflow governed models for early fault detection in any supply chain life cycle. Those are a few use cases which I can tell you of. For more detailed conversation, we can connect separately.
Yeah. Thank you so much, Viresh, for answering that question. Another question from Kajal. How does Databricks MLOps prove to be better than SageMaker?
So I'll take that one as well. So, from my understanding, SageMaker typically works in isolation and requires multiple integrations, whereas MLOps on Databricks is fundamentally stronger because it is built natively on the Lakehouse architecture. So that what that means is it unifies data engineering and model development, deployment, and governance all in one platform. So to summarize it, you are basically reducing the silos, lowering your costs, enabling faster and more reliable model deployment through Databricks MLOps in comparison to SageMaker.
Yeah, I guess that answers that. We have another question. Actually, we have Devang Talavia asking for any materials. I think it was addressed to Abhishek, but we would like to take it, Viresh.
Yeah, so we have the Databricks Partner Academy, where in this Partner Academy, there are a lot of resources which power up the MLOps model. And there is the Databricks official YouTube channel as well, wherein there are several videos which tell you about the different use cases on MLOps and how to power them up. So I think those are the materials that we can start with. And once you keep growing, then there are more courses or certifications also which are present on the ML lifecycle.
I'm sure that's really helpful. Thank you so much, Viresh and Rohit. Thank you so much for all your insights as well as answering all the questions today. Um, so, just to quickly recap before we call it a day, we learned how Databricks provides a unified platform for building, deploying, and scaling predictive models. We saw how MLOps reduces manual effort, increases reliability, and accelerates time to market for analytic solutions. And most importantly, we explored real world use cases where predictive analytics is driving tangible business outcomes. Thank you so much to everyone, to all our audience for joining, and thank you so much for your engaging questions. We hope you found this session insightful and relevant to your own data and AI journey. So, this webinar was the part of our Powering Your Future with AI series. So, please stay tuned for our upcoming sessions where we'll continue to bring more enterprise focused discussions on the future of AI. Thank you and have a nice day.